Welcome to a quiet corner where time slows, curiosity can wander freely, and the story of Earth unfolds like a slow, ancient melody. Tonight, we are not visiting the present. Instead, we journey far back, to an era so remote that the ground beneath your feet would feel utterly unfamiliar. This is a time long before our modern oceans carved their paths, before continents assumed the familiar shapes we recognize today, and even before maps could capture the world's layout. This is the age of Pangea, a single, immense continent stretching across most of the planet, uniting nearly all terrestrial land into one unbroken expanse. Though many have heard the name in passing, few truly imagine the experience of standing on this primeval land. Picture a horizon uninterrupted by ocean waves, a sky unmarked by distant continents. There was no Atlantic Ocean splitting the Americas from Europe or Africa, and the Pacific did not cleave the world in two. Instead, the land rolled endlessly, inviting travelers to cross from present-day North America into Europe and Asia, and then down into Africa or South America, all without touching a single ocean. Land extended farther than the eye could see, bordered by a massive, encircling ocean. A ring of water embracing the supercontinent, Pangea was far from still. Beneath its surface, immense forces were at work. Continents were slowly converging, mountains were thrust skyward, valleys were carved deep into the crust, and volcanoes spewed molten rock and ash, painting the skies with fiery streaks. Far from the coasts, life endured harsh climates. Summers baked the land in relentless heat, while winters could bite with piercing cold. Moisture was scarce, the air dry, and the horizon stretched unbroken except for jagged mountain peaks or forests that had learned to survive under these demanding conditions. Yet life flourished. Towering plants carpeted vast stretches, while in other regions, red deserts stretched toward the horizon. Creatures unfamiliar to us roamed freely, reptiles with hints of early mammalian traits, insects far larger than today's giants. This was a world alive but governed by different rules, shaped by a unique balance of isolation and connectedness. The lack of geographic barriers meant rivers could travel from one end of the supercontinent to the other, and forests could span regions that would eventually become separate continents. Animal species moved freely across vast terrains. Pangea was a single, unified world, a landmass unbroken by the oceans that now divide our Earth. Yet, nothing on this planet is permanent. The same forces that bound Pangea together were also preparing its eventual fragmentation. Continents drift, oceans expand and shrink, and mountains rise only to erode. Pangea's story is written in stone and soil, leaving lasting marks on the evolution of life and on the foundations of the modern world. To truly understand this world, we must trace the slow, persistent movements of Earth's tectonic plates. The Earth's crust rests atop a hot, fluid layer, broken into enormous plates that glide imperceptibly over the surface. Though the plates move only centimeters per year, over millions of years, these subtle motions reshape the entire planet. Long before Pangea, other supercontinents existed: Rodinia, Nuna, and others whose names are whispered in classrooms and rarely beyond. They collided, fractured, drifted apart, and set the stage for the formation of this enormous land. Over countless millions of years, smaller continents merged, forming ever larger landmasses. Each collision raised mountain ranges, stretched stone across the sky, and left scars still visible in today's bedrock. Eventually, all these fragments fused into a single, vast continent. Imagine standing in the heart of Pangea, thousands of kilometers from the nearest ocean. The climate was extreme, the air dry, and the scent of salt entirely absent. This was the world of continental interiors, isolated yet fertile ground for evolution. Isolation shaped life in profound ways. Insects grew larger, reptiles adapted to endure the arid heat, and coastal regions developed lush corridors for life to spread. It was in this crucible of extremes and connected landscapes that ancestors of dinosaurs, mammals, and early birds began to emerge. Volcanoes reshaped the land, rivers carved valleys, and deserts expanded and contracted with the seasons. Pangea was a dynamic, living entity, vast yet bound together in a delicate, ever-moving balance. Even the winds moved differently. Without oceans to disrupt their paths, air could sweep uninterrupted across thousands of kilometers, carrying dust from inland deserts to nourish forests far away. Storms traveled unbroken by seas, influencing climate on a continental scale. Every sunrise illuminated a horizon stretching endlessly, a single, colossal Earth beneath one sky, unbroken by distant continents. Long before Pangea's lands were joined, the Earth was a mosaic of drifting continents and scattered island chains, each moving at its own slow pace across a vast, ancient ocean. These fragments were never still for long, carried along by the slow, almost imperceptible motion of tectonic plates. Over millions of years, collisions raised mountains, splits created new seas, and gradual shifts nudged these land pieces closer together. Every subtle movement was a step toward the emergence of a single, unified supercontinent. By the late Paleozoic era, roughly 300 million years ago, several large continental blocks were already traversing the planet. Laurentia, destined to become North America, drifted alongside Gondwana, the future home to South America, Africa, Antarctica, Australia, and India. Smaller land masses like Baltica and Siberia also meandered across the seas. Each drift, each approach, set the stage for inevitable encounters, bringing distant lands together to form something far greater than themselves. The history of supercontinents is a story of cycles: assembly, fragmentation, and drift. Long before Pangea, Rodinia existed nearly 1 billion years ago. It eventually shattered, scattering its fragments, only for some to regroup later into another supercontinent called Pangaea, which itself was temporary. These cycles repeat across geological time, a rhythm of creation and disintegration governed by the restless crust of our planet. As these landmasses approached one another, oceans slowly vanished. The Reich Ocean, for example, once lay between an early North America-Europe fusion called Laurussia and Gondwana. Over countless millennia, it shrank until it disappeared entirely, leaving the continents locked in a growing embrace. When land meets land, the collision is anything but gentle. Rocks buckle and fold under tremendous pressure, forming mountain ranges that stretch toward the sky. Valleys plunge deep, rivers carve paths through the crust, and volcanic activity becomes a constant painter of the horizon. Inside the vast interior of Pangea, life adapted to extraordinary conditions. Far from moisture-rich coasts, the air was dry, and seasons swung between extremes. Insects evolved to larger sizes, perhaps fueled by higher atmospheric oxygen. Reptiles learned to withstand scorching heat and limited water supplies. Forests near the edges of the continent acted as highways for life to disperse across the land, connecting distant ecosystems. In this crucible of extremes, the ancestors of dinosaurs, mammals, and birds gradually emerged, setting the stage for the future of Earth's biodiversity. The land itself bore the marks of constant upheaval. Volcanoes erupted with dramatic fury, spewing ash that enriched soils over time. Rivers, fed by melting mountains, carved long valleys, and transported minerals across vast distances. Deserts expanded and contracted, creating temporary barriers and corridors for migration. The Earth was alive, dynamic, and interconnected. In Pangea, the absence of dividing oceans allowed winds to travel uninterrupted, storms to sweep across continents, and dust from faraway deserts to nourish forests miles away. Imagine standing in this ancient interior, a horizon that seems endless, sky unbroken by distant lands, air carrying the dry, dusty scent of vast plains, mountains rising like jagged teeth in the distance, and forests clustered in green pockets along rivers. Here, life endured, evolved, and adapted in ways the modern observer can barely comprehend. Even the very atmosphere of Pangea would have felt different. Without the moderating influence of oceans, temperatures could soar under the summer sun and plummet in winter nights. Winds, unimpeded by seas, traveled thousands of kilometers, connecting distant ecosystems in subtle ways. Dust from deserts fertilized forests far away, carrying nutrients across regions that today are separated by vast waters. The climate, weather, and life of this ancient supercontinent were intricately intertwined, each element influencing the other on a scale almost unimaginable to us now. Every mountain, river, and valley was a testament to the power of slow, persistent forces beneath the Earth's surface. Continents pressed together, folded upon themselves, and sculpted the landscape. Insects, reptiles, and early plants thrived and diversified in response to these new environmental pressures. Pangea was not merely a mass of land, it was a living laboratory, where evolution experimented with new forms of life and where the foundations of future ecosystems were laid. The story of Pangea is thus one of both unity and motion. A single landmass stretched across the globe, yet it was anything but static. It was a dynamic, breathing entity, shaped by the relentless tug of tectonic forces, the flow of rivers, the rise of mountains, and the spread of life across immense, connected territories. In this age, the Earth was at once harsh, dramatic, and profoundly alive, preparing both for the era of Pangea's dominance and the eventual fracturing that would give rise to the continents we know today. As Pangea slowly took shape, the world beneath it was alive with ceaseless motion. Mountains thrust upward, valleys sank, and volcanoes erupted in magnificent displays of molten rock and ash, shaping landscapes that would endure for hundreds of millions of years. Each collision of continental plates left scars etched deep into the crust, silent reminders of a world governed by forces far greater than any living creature could influence. The Earth in this age was not merely a stage for life. It was an active participant, reshaping itself constantly while life adapted, endured, and flourished upon it. The interior regions of Pangea, far from the moderating influence of oceans, presented extreme climates. Summers could scorch the land, turning plains into ovens of sun-baked soil, while winters brought cold that could bite through even the most resilient foliage. Moisture was a rare gift, confined largely to regions near rivers, lakes, or seasonal floodplains. The wind moved without obstruction, carrying dust and nutrients across continents, fertilizing forests thousands of kilometers away. Insects grew larger, perhaps thriving in higher oxygen levels, and reptiles developed adaptations to endure intense heat, limited water, and the seasonal swings of temperature. Life in every corner found a way to survive under these unyielding conditions. Forests, however, were far from uniform. Some regions were dense and humid, sheltering a complex web of plants and animals, while others were scattered green patches in vast expanses of red or yellow deserts. These green corridors allowed species to migrate freely across what would much later become separate continents, ensuring genetic diversity and creating opportunities for evolutionary experiments. Here, ancestors of dinosaurs, mammals, and even early birds began to diversify, setting in motion the long story of life that would continue for hundreds of millions of years. Rivers carved intricate networks across Pangea, linking distant regions. A river beginning in the highlands of what would become present-day Asia could wind its way across thousands of kilometers to lands that centuries later would be known as Europe, uninterrupted by oceans. The sheer scale of these waterways dwarfed anything familiar to us today. Seasonal floods reshaped floodplains, deposited nutrient-rich sediments, and sustained life in the most remote areas. Forests and wetlands formed along these veins of water, creating oases in otherwise harsh landscapes. Volcanoes were both destroyers and creators. Their eruptions could blanket vast areas in ash, annihilating forests and filling valleys with molten rock. Yet over time, the ash and minerals they deposited fertilized soils, providing the foundation for new plant growth. Mountains rose abruptly, their peaks piercing the sky, creating rain shadows and affecting wind patterns. The landscape was in constant flux. Deserts expanded and contracted, forests shifted, rivers carved new channels, and entire ecosystems adapted to these changes. Even the atmosphere behaved differently. Without vast oceans to break wind patterns, storms could travel uninterrupted across thousands of kilometers. Dust storms from arid interiors could fertilize distant forests, while cyclonic winds shaped weather across multiple regions simultaneously. The climate of Pangea was interconnected in ways that modern observers can scarcely imagine. Every storm, every gust of wind, every seasonal shift had repercussions across the continent, linking ecosystems separated by thousands of kilometers yet unified under one sky. Life itself reflected the magnitude and interconnectedness of this supercontinent. Giant insects crawled across the forest floors, their immense size enabled by the rich oxygen levels of the atmosphere. Reptiles, some with unusual adaptations hinting at the eventual rise of mammals, roamed deserts and forests alike. Plants evolved to survive in extremes, with some species developing deep roots to access scarce water and others growing vast canopies to trap every drop of sunlight. Each organism, from the smallest insect to the largest reptile, played a part in an intricate web of ecological interactions shaped by the unique environment of Pangea. Even from a human perspective, imagining this world stretches the mind. Standing in the interior, one would see horizons unbroken by oceans, mountains looming in the distance, and forests scattered across vast plains. The air would feel drier and thinner in some regions, carrying scents of distant deserts, rivers, and volcanoes. The temperature swings could be dramatic, yet life thrived regardless. Observing the winds, the rivers, and the landscapes, it becomes clear that Earth in the age of Pangea was not simply a landmass. It was an ecosystem of interconnected processes, constantly shifting yet profoundly unified. The story of Pangea is also a story of cycles. Continents drift, oceans close and reopen, mountains rise and crumble, and life evolves in response. This supercontinent, though massive, was never permanent. It bore witness to the slow, unstoppable forces of tectonics, to the relentless shaping of landscapes, and to the emergence of life forms that would leave their mark on the planet for millions of years. It was an age of connection, isolation, extremes, and adaptation. A world both alien and familiar, alive and ceaselessly changing, laying the foundations for the Earth we know today. By the time Pangea reached its full form, the Earth was a dynamic and restless world, a place where the land itself seemed to breathe with ceaseless motion. Mountains were pushed skyward with immense pressure, valleys sank and shifted, rivers carved intricate networks across vast expanses, and volcanoes erupted continuously, blanketing large areas with ash and molten rock. These processes occurred over millions of years, imperceptible to a human lifetime, yet over geological time they reshaped the face of the planet entirely. The interior of Pangea, far removed from the moderating influence of oceans, experienced extremes of temperature and climate that would have been alien to any modern observer. Summers baked the plains with scorching heat, winters cut through the land with biting cold, and precipitation was rare, concentrated only near rivers, lakes, or seasonal floodplains. Winds traveled unimpeded across thousands of kilometers, carrying dust from arid interiors to nourish distant forests and fertilize fertile lands far away. Insects grew to sizes larger than anything seen in modern times, likely due to higher oxygen concentrations, while reptiles developed intricate adaptations to survive in the dry, harsh interior climates. Forests varied in density, from thick and lush corridors providing refuge for countless species to scattered patches isolated amidst expansive deserts. These green corridors allowed species to migrate freely across Pangea, maintaining genetic diversity and encouraging evolutionary experimentation. Early ancestors of dinosaurs, mammals, and birds began to emerge within this crucible of connected, yet extreme environments. Volcanoes, far from being solely destructive, deposited nutrient-rich ash that over time created fertile soils, allowing plant life to flourish in regions previously inhospitable. Rivers carved valleys that stretched for hundreds or thousands of kilometers, transporting minerals and sediments that sustained ecosystems far from their points of origin. Deserts expanded and contracted seasonally, creating dynamic barriers and pathways that shaped the movement of species. The climate of Pangea was interconnected on an unprecedented scale. Without oceans to disrupt wind patterns, storms traveled uninterrupted across vast distances, and dust storms from distant deserts could fertilize forests thousands of kilometers away. Seasonal changes and extreme weather events impacted not just local environments but entire regions, linking ecosystems separated by great distances into a unified, interdependent system. From a hypothetical vantage point standing in the interior of Pangea, one would see an endless horizon, punctuated only by jagged mountain peaks, scattered forests, and shifting rivers. The air would carry the dry scent of distant deserts mingled with the richness of fertile plains, and temperatures could swing dramatically between day and night or across seasons. Life adapted to these conditions in remarkable ways, evolving larger body sizes, intricate physiological adaptations, and behaviors tailored to the extremes of this connected yet isolated world. The story of Pangea is a story of perpetual motion, of a landmass constantly reshaped by the tectonic forces beneath it, yet maintaining a profound unity across continents. It is a world where mountains, rivers, forests, deserts, and the atmosphere are interconnected in ways that modern observers can scarcely imagine. Each eruption, flood, or seasonal shift influenced distant ecosystems, demonstrating the intricate balance and interdependence of this supercontinent. Life itself reflected the vastness and complexity of Pangea, with insects, reptiles, and plants evolving unique traits in response to environmental pressures and opportunities. Rivers acted as highways for migration, volcanoes as architects of new fertile lands, deserts as both obstacles and refuges, and forests as cradles of life and biodiversity. Winds and storms transported nutrients and shaped weather patterns across thousands of kilometers, linking distant ecosystems in a way that could only exist on a world united under a single landmass. Standing in such a landscape, one could witness the Earth in motion, alive and unyielding, a planet defined not only by its physical mass but by the ceaseless interplay of life and geology, where the past of Pangea would lay the foundations for the modern continents, ecosystems, and species that eventually arose. It was a world of extremes, yet profoundly connected, where every element, from the smallest insect to the largest mountain range, played a role in the ongoing narrative of our planet, a testament to the power of slow but relentless forces shaping both land and life over eons. Even as Pangea reached its zenith, the land remained in constant flux, shaped by invisible forces beneath the surface. Tectonic plates shifted ever so slowly, their motion imperceptible to a human lifespan but relentless across millions of years. Mountains continued to rise as continents collided, creating ranges that pierced the sky and carved shadows across deserts and plains. Valleys deepened, rivers changed their courses, and volcanic eruptions repeatedly transformed entire landscapes, scattering ash and lava across broad swaths of terrain. Life evolved in direct response to these monumental changes, adapting to extremes of temperature, scarcity of water, and the shifting mosaics of habitats. Insects grew enormous compared to modern standards, their exoskeletons strengthened to survive arid climates, while reptiles developed specialized traits to endure the scorching interior heat. Coastal regions, though smaller than today, provided vital refuges where early forests spread, creating corridors that allowed plants and animals to disperse across the vast continent. These green networks became lifelines for species survival, facilitating migration, reproduction, and diversification. The interior lands, isolated from the moderating influence of oceans, were subject to dramatic seasonal swings. Summers could scorch plains with unrelenting sun, winters could plunge the land into bitter cold, and precipitation was sparse, restricted to rivers, lakes, and occasional seasonal storms. Winds, unbroken by oceans, traveled thousands of kilometers, carrying dust, seeds, and nutrients from deserts to distant forests, linking ecosystems in ways unseen on modern Earth. Rivers carved intricate networks across the supercontinent, some spanning thousands of kilometers, connecting mountain ranges to distant plains, creating lifelines that sustained flora and fauna across vast expanses. Volcanoes, while destructive in the short term, enriched soils over time, providing fertile ground for new vegetation to flourish, enabling successive waves of ecological recovery and evolution. Deserts expanded and contracted, creating dynamic barriers and corridors that directed the movement and adaptation of species. Every ecosystem was interconnected through the flow of water, air, and nutrients, demonstrating the profound unity of life across Pangea. The atmosphere itself behaved differently than on modern Earth. Without oceans to disrupt patterns, storms traveled freely across the continent. Winds carried heat and dust uninterrupted, and air currents linked distant regions in complex and unseen ways. Life thrived within these conditions, each organism responding to environmental pressures with remarkable adaptations. Plants developed deep root systems to reach scarce water and broad canopies to maximize sunlight, while animals evolved behaviors and physical traits to survive in this demanding yet interconnected environment. Predators and prey coexisted in landscapes that stretched uninterrupted for thousands of kilometers, competing, migrating, and evolving as the land around them slowly transformed. From a hypothetical vantage point, the interior of Pangea would appear as an endless expanse of forests, deserts, rivers, and mountains, the horizon stretching far beyond what a human eye could comprehend. The air would carry a mixture of scents: dry dust from arid interiors, fertile minerals from volcanic soils, and the green aroma of forests nourished by distant rivers. Temperature extremes would dominate daily life, yet life endured and adapted with resilience. This was a world alive with motion and interconnected processes, where tectonic forces shaped the land, wind and water transported nutrients across continents, and ecosystems responded dynamically to change. Pangea was not merely a static landmass, but a living system in which every element, from the smallest insect to the largest mountain range, interacted, shaping and reshaping life and terrain alike. The history of this supercontinent demonstrates how geological and biological processes are intertwined, how life adapts to extremes, and how even the largest and seemingly permanent features of the Earth are transient in the face of relentless planetary forces. In the vast and connected landscapes of Pangea, life flourished not despite the challenges of isolation and climate extremes, but because of them, evolving strategies and forms that would echo across the ages and lay the groundwork for the diversity of species and ecosystems that would eventually inhabit the fragmented continents of the future. Imagine standing in the heart of Pangea, the great supercontinent that once stretched across nearly the entire planet, a vast expanse of land connecting future continents in a seamless sweep. The horizon seems endless, a continuous landscape interrupted only by jagged mountain ranges rising sharply from the plains, by forests clinging stubbornly to rivers, or by deserts stretching in waves of red and gold. The air is dry and carries the scent of distant lands, a mix of sun-baked soil, mineral-rich dust from inland deserts, and the subtle fragrance of forests nourished by waterways flowing thousands of kilometers from mountain highlands. Here, weather moves differently than it does in the modern world. Without oceans dividing continents, winds sweep across the land uninterrupted, storms travel vast distances, and the temperature swings dramatically between seasons. Summers can scorch the plains with relentless heat, while winters bring biting cold, particularly in the interior regions far from the influence of the coasts. Yet, life is everywhere, adapted to extremes, thriving despite, or perhaps because of, the challenges presented by this immense, unbroken continent. The land itself is alive with change. Mountains rise imperceptibly over centuries as tectonic plates collide beneath the crust, forcing rock upward into massive ranges. Valleys deepen, carved by rivers that travel thousands of kilometers, slowly wearing down stone and transporting minerals across the continent. Volcanoes erupt, often violently, blanketing the land in ash that eventually enriches the soil, creating pockets of fertile terrain amidst otherwise harsh environments. Deserts expand and contract with the seasons, forests shift in response to climate and precipitation, and rivers constantly alter their paths, reshaping ecosystems in their wake. Every change, every movement of land or air affects the interconnected web of life. Within this dynamic landscape, creatures evolve and adapt in ways that are both extraordinary and unexpected. Insects grow to enormous sizes, likely benefiting from higher oxygen concentrations in the atmosphere, and reptiles develop specialized adaptations to survive the dry, hot interiors. Early ancestors of dinosaurs, mammals, and even birds emerge, each exploring ecological niches created by the shifting geography and climate. Forests serve as corridors for migration, enabling species to disperse across thousands of kilometers of connected land, maintaining genetic diversity and encouraging evolutionary experimentation. Rivers act as lifelines, carrying water, nutrients, and sediments that support life far from their points of origin. Volcanoes simultaneously destroy and create, wiping out local ecosystems while seeding fertile soils that allow new life to flourish. Dust storms from deserts travel across continents, depositing minerals in forests thousands of kilometers away, linking ecosystems in subtle but critical ways. Standing in such an environment, the scale of the supercontinent is overwhelming. One could traverse from regions corresponding to modern-day North America to Europe or Asia without encountering an ocean, moving across landscapes that vary from scorching deserts to dense forests, from rugged mountains to fertile floodplains. The unity of the land creates a unique set of opportunities and challenges for life. The absence of oceanic barriers allows species to migrate freely, yet isolation from distant coasts imposes extreme conditions on the interior fauna and flora. Climate and geography combine to create both refuges and deserts, corridors and barriers, shaping evolution in ways that would leave lasting legacies on the future continents once Pangea begins to fragment. The wind itself is a major force, carrying moisture, dust, and heat across vast distances. A single gust can traverse thousands of kilometers, influencing weather patterns, transporting seeds, and even shaping soil composition in remote forests. Storms are powerful, unimpeded by seas, sweeping across the supercontinent with immense force, affecting ecosystems far from their origin. Seasonal changes are intense. Summers bake the land under an unrelenting sun, turning soil to cracked clay in some regions, while winter freezes rivers and blankets mountains with frost, testing the resilience of life. Yet, organisms are remarkably adaptable. Plants evolve deep root systems to access scarce water, broad leaves to capture sunlight, and resilience to withstand temperature swings. Animals adapt physiologically and behaviorally, developing survival strategies for extreme heat, cold, and drought. Predator and prey coexist within vast, uninterrupted ranges, driving evolutionary arms races that span thousands of kilometers. Geological processes continue to shape the landscape in imperceptible yet relentless ways. Tectonic collisions create new mountains, split valleys, and generate volcanic activity that both destroys and creates habitats. Erosion and sediment deposition constantly reshape river valleys and plains, providing fresh opportunities for plant colonization and influencing migration paths for animals. The supercontinent is both stable and dynamic, a paradox of permanence and change, where land and life are inseparably intertwined. The diversity of ecosystems within Pangea is staggering. Deserts stretch for hundreds of kilometers, dotted with sparse vegetation and home to uniquely adapted reptiles and insects. Forests provide shaded havens for herbivorous and carnivorous species alike. Rivers and lakes offer water sources and fertile soils, and mountainous regions harbor cold-adapted species. Each environment contributes to the overall balance of the supercontinent, supporting life while presenting challenges that shape evolution. This is a world of extremes, yet life persists and thrives. The vastness of Pangea allows for ecological experimentation on a scale impossible in modern fragmented continents. Species spread, adapt, compete, and evolve in continuous, interconnected landscapes. The movement of tectonic plates, the flow of rivers, the rise of mountains, and the fury of volcanoes all interact with life in a continuous feedback loop, creating an ever-changing mosaic of ecosystems across the supercontinent. Atmospheric circulation links distant regions, transporting heat, moisture, and nutrients across thousands of kilometers, influencing growth, reproduction, and survival in ways that would be unimaginable on today's oceans-divided Earth. Dust from deserts nourishes distant forests, volcanic ash enriches plains, seasonal floods shape wetlands, and winds carry seeds across continents. Life is not simply surviving. It is experimenting, evolving, and preparing for the eventual fragmentation of Pangea, which will scatter species across the future continents of the modern world. The scale of time magnifies these processes. While human life is measured in decades, geological and evolutionary change occurs across millions of years. Mountains rise and erode, rivers carve valleys, climates shift gradually yet profoundly, and life responds continuously. This interplay of forces produces patterns and legacies still observable today, embedded in the bedrock, fossil record, and genetic lineage of modern species. In this supercontinent, every element of nature, land, air, water, and living organisms, is interconnected, influencing each other in intricate and profound ways. Pangea is a world of unity and motion, extremes and adaptation, connection and isolation. A living laboratory where the Earth's systems and life evolve together over unimaginably long timescales, setting the stage for the planet we recognize today. As Pangea continued its slow, imperceptible drift across the planet's surface, life thrived in ways both extraordinary and delicate, molded by the interplay of geography, climate, and tectonic forces. The supercontinent, immense and unbroken, presented vast expanses of interior lands far from the moderating influence of oceans. These regions experienced extreme fluctuations in temperature, with summers capable of scorching the soil and winters plunging the land into bitter cold. Rivers carved their way across these enormous distances, creating intricate networks that provided life with essential water and nutrients, while also serving as natural highways for migration. Forests, scattered in patches across deserts and plains, acted as corridors for species to move, adapt, and evolve, maintaining diversity across vast regions. The wind played a profound role in shaping ecosystems, carrying dust from arid interiors to distant forests, transporting seeds across thousands of kilometers, and influencing weather patterns that connected seemingly distant regions in subtle but essential ways. Volcanic activity, while destructive in local areas, enriched the soil over time, enabling new plant life to colonize previously barren areas and providing habitats for animals that could exploit these fertile zones. Deserts expanded and contracted, creating shifting barriers and corridors that shaped the movement and behavior of animals, while mountain ranges acted both as obstacles and as refuges for species adapted to cold or high-altitude environments. Insects grew to enormous sizes, benefiting from higher oxygen concentrations, while reptiles evolved diverse adaptations to withstand extreme heat, aridity, and seasonal changes. Early ancestors of dinosaurs, mammals, and birds explored the ecological niches created by the unique combination of connected land, extreme climates, and dynamic landscapes, setting the stage for future evolutionary developments. Rivers, flowing uninterrupted across thousands of kilometers, deposited nutrient-rich sediments that fertilized forests and plains, connecting distant regions ecologically and allowing species to disperse and interact over vast distances. Volcanoes, mountains, and rivers work together to create an ever-changing mosaic of habitats, where destruction and creation were inseparable aspects of the same processes. Storms and atmospheric currents traveled across the supercontinent with minimal interruption, redistributing heat, moisture, and nutrients, shaping ecosystems in ways that would be impossible on a modern world divided by oceans. The scale of Pangea allowed for ecological experimentation on a continental level. Species could spread across thousands of kilometers, adapt to different climates, and evolve in response to pressures created by both the environment and competition with other organisms. Life in this supercontinent was not static. It was in a constant state of adaptation, responding to the shifting landforms, fluctuating climates, and evolving ecosystems. Forests spread and receded, deserts waxed and waned. Rivers carved new valleys and altered their courses, and the mountains themselves changed shape over millions of years, rising and eroding in response to tectonic pressures. Within this grand stage, predator and prey coexisted, competed, and evolved across massive ranges, leading to the development of diverse physical traits, behaviors, and survival strategies. The interior lands of Pangea were particularly extreme, challenging life to survive without the moderating influence of nearby oceans. Summers could last for months under unrelenting sun, turning soil to cracked clay, while winters brought frost and freezing temperatures that tested the endurance of plants and animals alike. Yet life adapted, evolving physiological and behavioral mechanisms to endure these extremes. Forests provided shaded refuge, rivers offered reliable water and nutrients, and mountain ranges offered cooler, more stable environments. The connectivity of the supercontinent allowed species to disperse widely, maintaining genetic diversity and enabling evolutionary innovations that would influence life long after Pangea began to break apart. Tectonic forces continued their slow but relentless reshaping of the land, producing mountains, valleys, and volcanic activity that constantly altered habitats. Erosion and sediment deposition redistributed minerals and soils, enriching some regions while creating new challenges in others. These processes, occurring over millions of years, were subtle yet transformative, establishing the patterns and landscapes that life adapted to over geologic time. The atmosphere and climate were also unique. Without oceans breaking up circulation patterns, winds could travel uninterrupted across the supercontinent. Storms moved vast distances, and dust and nutrients were transported across ecological zones, creating unexpected connections between distant regions. This interconnectedness of land, air, and life shaped ecosystems on a scale unseen in modern continents. Every species, from the smallest insect to the largest reptile, was part of an intricate web linking disparate parts of the continent, responding to the constant interplay of environmental factors, migration opportunities, and evolutionary pressures. Pangea was more than a landmass. It was a living system, where the Earth's geological forces and the life they supported interacted continuously, shaping and reshaping one another. The supercontinent's vastness allowed life to explore ecological possibilities, adapt to extreme conditions, and evolve in ways that would leave enduring legacies long after the land eventually fragmented into the continents we know today. The scale, complexity, and dynamism of Pangea are difficult to fully grasp, yet they illustrate the profound interconnectedness of the Earth's systems, the adaptability of life, and the intricate relationship between geography, climate, and evolution across a vast, unbroken landscape that existed hundreds of millions of years ago. The story of Pangea is a story of motion, evolution, and interconnectedness, a world where life and land coexisted in a continuous dance across vast stretches of unbroken territory. Imagine traveling across the supercontinent, from what will one day be North America, across plains and mountains, deserts and rivers, to regions that correspond to modern Europe, Asia, or Africa, all without ever touching an ocean. The scale is unimaginable, the landscape changing gradually yet persistently over millions of years, shaped by tectonic forces beneath the Earth's crust. Mountains slowly rose as plates collided, forming ranges that stretched for thousands of kilometers, casting long shadows over deserts and valleys. Volcanoes erupted repeatedly, spewing ash and lava, destroying local ecosystems while simultaneously enriching the soil for new growth. Rivers flowed endlessly, carving valleys, transporting sediments, and connecting distant ecosystems, providing lifelines for plants and animals alike. The atmosphere and climate were unlike anything experienced today. Winds moved across the supercontinent without interruption. Storms traveled great distances, and dust from arid interiors fertilized forests thousands of kilometers away. Summers in the interior could scorch the land under a relentless sun, while winters brought intense cold, freezing rivers and testing the resilience of plants and animals. Yet life thrived. Insects grew larger than modern analogs. Reptiles developed sophisticated adaptations to heat and aridity, and early ancestors of dinosaurs, mammals, and birds explored niches shaped by climate and geography. Forests created corridors for migration, rivers supplied nutrients and water, and mountains offered cooler, more stable environments for species survival. Predators and prey coexisted over vast territories, driving evolutionary pressures that resulted in remarkable diversity of form and behavior. The supercontinent's vastness allowed ecological experimentation on a scale impossible in today's fragmented continents. Species could migrate thousands of kilometers, adapt to different climates, and evolve in response to both competition and environmental challenges. Deserts expanded and contracted seasonally, creating shifting barriers and corridors, while volcanoes destroyed local habitats but enriched the land for new life. Forests flourished along rivers, deserts provided unique adaptations, and mountains served as both obstacles and refuges. These ecosystems were interconnected across vast distances, forming a web of life that responded to tectonic activity, erosion, atmospheric patterns, and seasonal changes. Life was not simply surviving. It was actively experimenting, adapting, and evolving in response to the challenges and opportunities provided by a supercontinent. The slow motion of tectonic plates reshaped mountains, created new valleys, and produced volcanic activity that continuously altered habitats, forcing species to adapt over geologic timescales. Erosion redistributed sediments, forming fertile plains and riverbeds, while climate fluctuations influenced vegetation, migration, and evolutionary pressures. The wind carried moisture, heat, and nutrients, connecting regions that would one day be separated by vast oceans. Species adapted to these conditions in remarkable ways. Plants developed deep root systems, broad canopies, and drought-resistant traits, while animals evolved behavioral and physiological strategies to survive extreme heat, cold, and aridity. The interconnectedness of Pangea created an environment where adaptation, migration, and evolution occurred across continental scales. Life was constantly responding to shifting landscapes, changing climates, and interactions with other species. Forests and rivers connected regions ecologically, deserts acted as selective pressures, and mountains provided stability and shelter. Evolutionary innovation was encouraged by the vastness and diversity of environments within a single landmass. Pangea was a laboratory of life, tectonics, and climate, where slow, persistent geological forces shaped the landscapes and life that inhabited them. The atmosphere, rivers, mountains, and volcanic activity all worked together to create a dynamic yet connected ecosystem. Species dispersed widely, evolved in response to extremes, and explored ecological possibilities that would influence the biodiversity of the modern continents. The scale of Pangea amplified the effects of climate, tectonics, and ecological interactions, creating patterns of life that would echo through time. Every element of the supercontinent, from the smallest insect to the largest mountain range, was interconnected, influencing and being influenced by others. Life evolved not in isolation but as part of a vast, integrated system spanning thousands of kilometers. Winds transported seeds, nutrients, and dust across regions. Rivers connected distant habitats, and volcanic eruptions reshaped the land while enriching it for new growth. Predators and prey coexisted across massive ranges, competition drove adaptation, and ecosystems continually responded to environmental change. This was a living world, in constant motion, dynamic and interconnected, where life adapted, evolved, and prepared for the eventual fragmentation that would scatter species across the future continents. Pangea, though immense and seemingly permanent, was itself temporary. The same tectonic forces that held it together also set the stage for its eventual division, creating new oceans and reshaping life's distribution across the planet. Yet while it existed, it was a world of extraordinary scale, extremes, and opportunity, a unified landmass where life and geology intertwined in complex and profound ways, leaving legacies still observable in the fossil record, geology, and genetic lineage of species millions of years later. The story of Pangea demonstrates the interconnectedness of life and the Earth systems, the adaptive power of organisms in extreme conditions, and the continuous influence of tectonic and climatic forces in shaping landscapes and life on a planetary scale. In every river, mountain, desert, forest, and storm, one can trace the story of a supercontinent that was alive, dynamic, and endlessly evolving, a world that laid the foundations for the Earth we inhabit today. The interior of Pangea, far from the influence of the seas, presented a world of extremes that tested the endurance and adaptability of every living organism. Summers baked the plains with relentless heat, turning soil into cracked, lifeless clay, while winters plunged the land into biting cold that froze rivers and coated mountains with frost. Rain was scarce, confined mostly to rivers, lakes, and seasonal floodplains, leaving the interior a mosaic of deserts, plains, and scattered forests. Despite these challenges, life thrived, evolving unique adaptations to survive in this harsh but interconnected environment. Insects, benefiting from higher oxygen concentrations, reached enormous sizes, while reptiles developed specialized physiological traits to endure heat, aridity, and seasonal fluctuations. Forests formed green corridors along rivers and valleys, allowing species to migrate, disperse, and maintain genetic diversity across thousands of kilometers of continuous land. Rivers themselves were lifelines, carrying water and mineral-rich sediments from mountains to plains, connecting distant ecosystems and supporting plant and animal life across the supercontinent. Volcanoes were both destructive and creative, destroying local habitats while depositing fertile ash that enabled new plant growth and provided niches for animals to exploit. Deserts expanded and contracted with the seasons, creating dynamic barriers and opportunities for species migration and evolution. Predators and prey coexisted in vast, uninterrupted territories, driving evolutionary pressures that shaped anatomy, behavior, and survival strategies across multiple generations. The winds, unimpeded by oceans, carried moisture, dust, and seeds across immense distances, linking ecosystems in subtle but profound ways. Storms traveled across thousands of kilometers, influencing climates and life far from their origins. while atmospheric currents redistributed heat and nutrients, creating a delicate balance that connected distant regions ecologically. Within this immense landmass, life explored ecological possibilities on a continental scale, evolving strategies to cope with extremes, migrating across diverse landscapes, and experimenting with behaviors and traits that would echo through evolutionary history. Mountains rose imperceptibly over millennia, shaped by tectonic collisions, creating peaks and valleys that influenced climate, redirected rivers, and offered habitats for species adapted to cooler or high-altitude environments. Erosion continually reshaped valleys, plains, and riverbanks, redistributing minerals and creating fertile soils that supported new generations of plants and animals. Forests expanded and contracted in response to seasonal rainfall, deserts shifted with climate cycles, and river courses altered, demonstrating the dynamic interplay between geology, climate, and biology. Life was not static. It evolved in concert with these forces, adapting continuously to the challenges of the supercontinent. The vastness of Pangea allowed species to spread over thousands of kilometers, maintaining genetic diversity and enabling evolutionary experimentation that would not have been possible on fragmented continents. The interconnectedness of ecosystems, facilitated by uninterrupted land, rivers, and wind, created a web of life that spanned the entire supercontinent. Predators evolved to chase prey over immense ranges. Herbivores developed adaptations to survive in deserts and forests alike, and insects and small animals adapted to extremes of temperature, moisture, and food availability. Volcanic eruptions, mountain formation, erosion, and sediment deposition were not merely geological processes. They were integral parts of the ecological system, influencing where species could survive, how they adapted, and how ecosystems were structured. The climate of Pangea was unique, with weather systems traveling vast distances without obstruction, winds distributing heat, moisture, and nutrients, and dust from deserts fertilizing distant forests. Seasonal extremes drove adaptations, influencing reproductive cycles, migration, and survival strategies. Life evolved in response to both predictable and unpredictable changes, thriving in a landscape that demanded resilience, flexibility, and ingenuity. Rivers, fed by melting mountains, transported sediments that created fertile plains far downstream, while mountains themselves influenced rainfall patterns and created microclimates within the vast continent. Forests provided shelter and resources, deserts acted as selective pressures, and plains allowed for wide dispersal and migration. The supercontinent was simultaneously a laboratory of evolution, a stage for geological processes, and a living system in which every element, land, air, water, and organism, was interconnected. Over millions of years, these interactions shaped the development of early dinosaurs, mammals, birds, and other forms of life, each adapting to specific niches created by climate, geography, and the movements of tectonic plates. Species spread across the supercontinent, adapted to a variety of habitats, and responded to environmental pressures in ways that would leave lasting legacies on the ecosystems of the future. The scale, diversity, and dynamism of Pangea allowed life to explore evolutionary paths that were unprecedented in Earth's history. Predators hunted across wide ranges, prey adapted to survive in multiple environments, and plant life diversified in response to soil, water availability, and climate conditions. The interdependence of these systems, spanning thousands of kilometers, created a living network of ecological interactions that was both resilient and delicate. Winds carried nutrients, rivers connected habitats, volcanoes shaped the land, and life evolved within this complex web, responding to the constant interplay of forces that defined the supercontinent. Pangea's story is one of unity, diversity, and ceaseless motion, where geology and biology were inseparable, and where the vast, connected land allowed life to thrive and innovate in ways that would shape the planet for millions of years to come. Even as the continent would eventually fragment, giving rise to the modern continents we know today, the legacy of Pangea's ecosystems, climates, and evolutionary experiments continued, leaving traces in fossils, sediment layers, and the genetic lineage of countless species. Standing hypothetically in the interior of Pangea, one would witness an interconnected world of mountains, rivers, deserts, forests, and life, all bound together under a single sky, shaped by forces moving both above and beneath the earth, and sustained by the extraordinary adaptability of organisms evolving in concert with their environment. Life on Pangea was both immense in scale and delicate in its balance. A supercontinent where the forces of geology, climate, and biology intertwine to create ecosystems unlike any seen on the modern Earth. The land stretched unbroken across thousands of kilometers, connecting future continents in a seamless expanse of mountains, rivers, deserts, and forests. The interior regions, far from oceanic influence, were particularly extreme, with scorching summers and freezing winters shaping the adaptations of every species that lived there. Rainfall was limited to rivers, lakes, and seasonal floods, creating pockets of life that depended on these vital water sources. The wind carried moisture, dust, and seeds across vast distances, linking ecosystems ecologically and influencing the growth, reproduction, and survival of plants and animals. Rivers acted as lifelines, transporting sediments from mountains to plains, nourishing forests and wetlands, and providing routes for migration across immense distances. Forests formed corridors that allowed species to disperse, maintain genetic diversity, and explore new habitats. Deserts, though harsh, created selective pressures that drove evolutionary innovation, while volcanic activity, though destructive, enriched soils and created new ecological niches for colonization. Life evolved in response to these interacting forces, with insects growing to enormous sizes, reptiles developing adaptations to heat and aridity, and early ancestors of dinosaurs, mammals, and birds exploring the vast ecological possibilities of the supercontinent. Predators and prey interacted across continuous ranges, creating evolutionary pressures that shaped behavior, anatomy, and survival strategies over millions of years. The interconnectedness of ecosystems across Pangea allowed species to adapt to environmental changes while maintaining widespread populations. Mountains influenced climate patterns, creating rain shadows, redirecting rivers, and providing cooler, more stable habitats for species adapted to high altitudes or cold conditions. Erosion reshaped valleys and plains, depositing fertile soils that enabled plant life to flourish and supported complex food webs. Volcanic eruptions repeatedly transformed the landscape, destroying local ecosystems while simultaneously creating opportunities for new growth. The wind carried dust and nutrients from deserts to distant forests, connecting seemingly separate regions into a cohesive ecological system. Seasonal extremes forced species to adapt physiologically, behaviorally, and reproductively, with plants and animals developing strategies to survive both heat and cold, drought and flood. The scale of the supercontinent enabled evolutionary experiments on a continental level. Species could disperse across thousands of kilometers, encounter new ecological challenges, and evolve traits that would endure long after Pangea fragmented. Rivers connected habitats, allowing aquatic and terrestrial species to migrate, while deserts and mountains provided selective pressures that shaped adaptation. Forests offered shelter and resources, supporting herbivores and predators alike, and contributing to complex interactions between species. Life was not static. It evolved continuously in response to shifting landforms, climatic fluctuations, and interactions with other organisms. The supercontinent's vastness allowed ecological innovation and diversification on an unprecedented scale, with species exploring multiple niches simultaneously, adapting to extremes, and maintaining resilience through dispersal and migration. Atmospheric currents and storms moved across the continent without obstruction, redistributing heat, moisture, and nutrients, creating interconnected weather and ecological patterns that linked regions thousands of kilometers apart. Dust storms fertilized distant forests, volcanic ash enriched soils, and seasonal floods replenished wetlands, demonstrating the profound interdependence of geological and biological systems. Tectonic activity continued to shape the land, gradually forming new mountains, splitting valleys, and producing volcanic eruptions that altered habitats and ecological dynamics. Erosion, sediment deposition, and river course changes continuously reshaped landscapes, influencing species distribution and adaptation. Life evolved in tandem with these forces, responding to environmental pressures with remarkable resilience, ingenuity, and diversity. The supercontinent acted as a vast laboratory, where evolution proceeded at scales and in ways that were impossible on fragmented continents. Predators hunted across extensive ranges, prey adapted to survive multiple environments, and plants developed strategies to exploit limited water and nutrient resources. The interconnectedness of Pangea created a living system in which land, water, air, and organisms influenced each other in profound and continuous ways. Even minor shifts in climate, tectonics, or river flow had cascading effects across thousands of kilometers, illustrating the sensitivity and complexity of the supercontinent's ecosystems. Life was continually adapting, evolving, and experimenting with new forms and behaviors, preparing for the eventual fragmentation of Pangea, which would scatter species across the future continents and reshape global biodiversity. The story of Pangea demonstrates the interplay of geological processes, climate, and evolution, showing how life can thrive in extreme and interconnected environments. It illustrates the adaptability of organisms, the resilience of ecosystems, and the profound influence of tectonic forces in shaping both land and life over millions of years. Standing hypothetically within the heart of Pangea, one would see an interconnected landscape of mountains, deserts, forests, rivers, and lakes, all under a single sky, all shaped by the ceaseless forces of the earth, and all hosting life that had adapted to thrive across the vast, unbroken expanse of the supercontinent. This world, immense and dynamic, provides a window into the processes that forged the continents, the evolution of species, and the enduring legacies of a unified Earth that existed hundreds of millions of years ago. As Pangea approached the culmination of its existence, the supercontinent was a living testament to the interplay of geological forces, climate, and evolution. Standing hypothetically anywhere within its vast interiors, one would witness landscapes of unparalleled scale. Mountains that rose like jagged spines across the land, valleys carved over eons by rivers flowing thousands of kilometers, deserts stretching in waves of red and gold, and forests that created corridors for life to move, reproduce, and adapt. The atmosphere itself was unique. Without oceans to divide the continent, winds traveled uninterrupted for thousands of kilometers, carrying heat, moisture, dust, and nutrients across the land. Storms swept across vast expanses, impacting ecosystems far from their origin. while seasonal extremes shaped the behavior and physiology of organisms. Summers could scorch the plains, turning soil to dry, cracked clay, while winters brought frost and ice that transformed rivers and mountain slopes. Yet life was not merely surviving. It was thriving, evolving, and experimenting with strategies to endure in extreme and interconnected environments. Insects grew to unprecedented sizes, likely aided by elevated oxygen levels, while reptiles evolved adaptations to cope with heat, drought, and seasonal fluctuations. Early ancestors of dinosaurs, mammals, and birds navigated vast ranges. As Pangea approached the culmination of its existence, the supercontinent was a living testament to the interplay of geological forces, climate, and evolution. Standing hypothetically anywhere within its vast interiors, one would witness landscapes of unparalleled scale. Mountains that rose like jagged spines across the land, valleys carved over eons by rivers flowing thousands of kilometers, deserts stretching in waves of red and gold, and forests that created corridors for life to move, reproduce, and adapt. The atmosphere itself was unique. Without oceans to divide the continent, winds traveled uninterrupted for thousands of kilometers, carrying heat, moisture, dust, and nutrients across the land. Storms swept across vast expanses, impacting ecosystems far from their origin, while seasonal extremes shaped the behavior and physiology of organisms. Summers could scorch the plains, turning soil to dry, cracked clay, while winters brought frost and ice that transformed rivers and mountain slopes. Yet life was not merely surviving. It was thriving, evolving, and experimenting with strategies to endure in extreme and interconnected environments. Insects grew to unprecedented sizes, likely aided by elevated oxygen levels, while reptiles evolved adaptations to cope with heat, drought, and seasonal fluctuations. Early ancestors of dinosaurs, mammals, and birds navigated vast ranges, exploiting ecological niches created by climate, geography, and the dynamic reshaping of the land. Rivers acted as lifelines, transporting water and mineral-rich sediments that nourished distant forests, creating fertile habitats, and linking ecosystems across thousands of kilometers. Forests served as corridors, allowing species to migrate, disperse, and maintain genetic diversity across the continent. Deserts, though harsh and challenging, imposed selective pressures that encouraged innovation in survival strategies, while volcanoes reshaped the land, destroying local habitats but simultaneously creating fertile soils and opportunities for colonization. Mountains influenced climate, redirecting winds and rivers, creating rain shadows, and providing cooler, more stable environments for species adapted to high altitudes. Erosion and sedimentation constantly altered plains and valleys, redistributing nutrients, creating fertile soils, and forming new habitats for colonizing life. Life evolved in continuous response to these forces, developing behaviors, physiological adaptations, and reproductive strategies to survive and thrive across the extremes of Pangea. Predators and prey coexisted in vast, uninterrupted ranges, driving evolutionary arms races that shaped anatomy, behavior, and survival strategies over millions of years. The interconnectedness of ecosystems allowed life to disperse widely, maintain genetic diversity, and explore ecological possibilities at scales impossible on modern fragmented continents. Atmospheric currents and wind patterns linked distant regions, moving heat, moisture, dust, and seeds across thousands of kilometers, creating ecological connections that tied the supercontinent into a cohesive system. Species evolved in response to both local and distant conditions, with plants adapting to soil and water availability, animals evolving to cope with temperature extremes, and migratory patterns shaped by interconnected rivers, valleys, and plains. The dynamic landmass was a laboratory of evolution, geological activity, and ecological interaction, with tectonic collisions forming new mountains, volcanic eruptions transforming habitats, and rivers continuously reshaping landscapes. Life adapted in concert with these changes, evolving in response to extreme climates, shifting habitats, and the interconnectedness of ecosystems across a single, unbroken continent. The sheer scale of Pangea allowed for continental-level ecological experiments, where species could occupy multiple habitats, disperse widely, and evolve complex strategies for survival. Forests, rivers, deserts, and mountains all contributed to a living network of interactions, creating a dynamic balance between life and environment. Winds carried nutrients and seeds across vast distances. Rivers linked distant ecosystems, and volcanic ash enriched soils, illustrating the interdependence of life and geology. Seasonal extremes tested the resilience of species, shaping behavior, reproduction, and physiology in ways that would leave lasting legacies on the future continents. As the supercontinent slowly began its eventual fragmentation, the adaptations, dispersals, and innovations that had occurred across its connected landscapes set the stage for the emergence of modern continents and their ecosystems. Life had already evolved strategies for survival and dispersal that would allow species to continue thriving once oceans split the land into separate continents. Predators and prey were distributed over extensive ranges, plants were diversified across various habitats, and insects, reptiles, and early mammals had adapted to a multitude of ecological niches. The fragmentation of Pangea would scatter species across new continents, creating isolated populations, stimulating further evolutionary change, and setting the stage for the biodiversity we observe today. Yet, even in its final stages, Pangea's landscapes remain dynamic, with mountains continuing to rise, valleys deepening, rivers shifting course, and volcanoes shaping the terrain. Climate and atmospheric circulation maintained interconnectivity across the landmass, influencing species movement, reproductive timing, and ecological relationships. Life evolved within this context of constant change, interconnectedness, and environmental extremes, creating a rich tapestry of adaptations that left an enduring imprint on Earth's history. Standing hypothetically in the heart of Pangea, one would witness the profound unity of the land, the interplay of geology and biology, and the resilience